This video is going to teach about transformations. I will use the equation y equals positive or negative a times positive or negative b plus or minus h squared plus or minus k as an example of how transformations can be used on a graph. This specific graph is a parabola, but it can also be used on any family of graphs. If a is greater than 1, the graph is stretched by a vertical factor of a. If a is greater than 0 but less than 1, the graph is compressed by a vertical factor of a. If a is positive, the parabola looks normal and faces upwards. But if a is negative, it is reflected about the x-axis and faces downwards. If b is negative, the graph is reflected about the y-axis because the x is negated. And if b is positive, the graph remains the same. If 1 over b is greater than 1, the graph is horizontally stretched by a factor of 1 over b. If 1 over b is greater than 0 and less than 1, the graph is horizontally compressed by a factor of 1 over b. If h is negative, the graph moves h units to the right. And if h is positive, the graph moves h units to the left. If k is positive, the graph is shifted k units up. If k is negative, the graph is shifted k units down. As an example, I'm going to show you how to transform this piecewise function for y equals negative 2x minus 2 when x is greater than or equal to negative 2 and less than 0, and y equals 2x minus 2 when x is greater than or equal to 0 and less than or equal to 2, using the transformations I spoke about before. When 1 is added to x inside the parentheses, the graph is moved 1 unit to the left. To find this new graph, you would subtract 1 from the original x and keep y the same. The new graph would look like this. When 1 is subtracted from x inside the parentheses, the graph is moved 1 unit to the right. To find this graph, you would add 1 to x and leave y the same. The new graph would look like this. When 1 is added to f of x outside of the parentheses, the graph is moved 1 unit up. To find this graph, you would add 1 to y and leave x the same. The transformed graph would look like this. 1 is subtracted from f of x outside the parentheses, this graph is moved 1 unit down. To find this new graph, 1 would subtract 1 from y and leave x the same. The new graph would look like this. When a negative is added to x inside the parentheses, the graph is reflected about the y-axis. To find this graph, you would negate the x and leave y the same. The new graph would look like this. When a negative is added to f of x, this graph is reflected about the x-axis. To find this graph, you would negate the y and leave x the same. The graph for negative f of x would look like this. When x is multiplied by 2 inside of the parentheses, this graph is horizontally compressed by a factor of 1/2. To find this new graph, you would multiply x by 1/2 and leave y the same. The new graph would look like this. When f of x is multiplied by 2, the graph is vertically stretched by a factor of 2. The new graph would be found by multiplying y by 2 and leaving x the same. The new graph would look like this. The graph of y equals x squared is a parabola symmetric about the y-axis. When 1 is added to y equals x squared, the graph is shifted 1 unit up. When 1 is added to x inside of the parentheses, the graph is moved 1 unit to the left. When x is made negative, the graph is reflected about the x-axis. Here, y is negated. When 2 is subtracted from x inside of the parentheses and 3 is subtracted outside of the parentheses, the graph is shifted 2 units to the right and 3 units down. When x is made negative inside of the parentheses, the graph is reflected about the y-axis. The graph looks the same because this graph is symmetrical about the y-axis. When x is multiplied by 2 inside of the parentheses, the graph will be twice as narrow as the original graph.